In the 21st century, people's mentality is focused only on progress, focusing on its positive aspect, but leaving out the negative ones.
With the invention of industries and cars, air pollution is becoming more and more dangerous every day. It is true that many green alternatives are being created, but air pollution is a hot issue nowadays, and this is where our project comes in.
We are Giovanni Mazzarini
and Matteo Mazzanti.
We come from the center of Italy and we are attending the final year of the Environmental Biotechnology course of WYSII Galileo Galilei Highschool. Our project is entitled Not to NOx, Breathe Clean Air and Produce Nitric Acid. And now you may ask, what does nitric acid have to do with progress and what are those NOx?
Well, NOx, commonly called nitrogen oxides, are one of the main substances responsible for air pollution and acid rains. They're also harmful to our body and to the environment. But what do nitrogen oxides have to do with progress?
These substances are produced during any combustion process. As the graph shows, during the last century, the emissions of nitrogen oxides have increased dramatically. As you may have already understood, our project aims to break down nitrogen oxides, but not seeing them just as pollutants, but as real resources, by turning them into nitric acid.
It sounds like science fiction, but it is true. With this simple reaction, we have shown that it is possible to capture nitrogen oxides and convert them into nitric acid only using water. But how does this process work?
We've created this method to collect and capture NOx. It is made of two bubblers placed in series connected to a pump that takes the air from the atmosphere. These bubblers are containers filled with deionized water. They break down the air into very small bubbles so that NOx can react more easily with water.
We also had another problem. We had to transform every nitrogen monoxide into nitrogen dioxide in order to make the reaction efficient. To do this, we created a system that uses UV lights to transform oxygen into ozone, which is a far better oxidizer than oxygen, making the reaction more efficient.
And now you may ask yourself, how do we ensure that this process is successful and how do we measure the amount of nitrogen oxides that have been captured and converted into nitric acid? Here is where the spectrophotometer comes in, an advanced tool that allows a substance to be detected and its concentration to be measured.
It works by recording the interaction between matter and light in the visible and in the near ultraviolet fields. The matter, in this case, is water took from our bubblers. Here are some graphs comparing potassium nitrate standards with ours.
This research is a proof of the power of innovative thinking and the potential of chemistry to tackle environmental challenges. Our research has dealt with the problem of a pollutant, which is not seen as a harmful byproduct of industrial processes, but as a real resource. It is not just a question of producing nitric acid, but also of thinking our approach to pollutants and their potential uses.
From an economic point of view, it presents us with a win-win situation. Nitric acid, the product of this process, is an incredible versatile compound in a wide range of industrial applications. It's used in the production of fertilizers and dyes, is fundamental in lab environments, and plays a key role in the metal processing and purification industry. Imagine a world where pollutants are not just reduced, but also repurposed.
That's the world we are building.